Hi, welcome to Tech Ranch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithm and implementation. Encryption using RSA algorithm. In this session, we are going to learn how to implement encryption using RSA algorithm in Java cryptography API. So before we start, let's learn what is actually a cryptography. Cryptography is the science of making information security algorithm with the actual securing of digital data. So in the simple words, if you see, we have a person called Bob. He is texting or messaging or communicating to his friends called Alice. Now he is sending a message. Because of the cryptography, that message is going to be encrypted, or it is going to be in a different format that a machine can interpret it and provide a public key. And this key will mix with this message and send it to your friend Alice, and it's going to decrypt that message, a kind of encoding and decoding, and then adding a private key to make it more secured, and the Alice will get his message from Bob with the actual text which he can understand and interpret it and decrypt it by the machine on its own with the help of this algorithm. So cryptography making this kind of system where you can send your friend's message in a secured system. Now after understanding about the concept of cryptography, let's see. There are two basic parts of cryptography we have to concentrate. One is called encryption and another is called decryption. Now, in this session, we are going to see about encryption. So what is happening in encryption? We have a plain text, a message, where a bank message to John that you have transferred this much amount in your account. Now, this is the most secured and confidential message. Now, encryption is going to use a personal or a private key, and using this key is going to encrypt in the message, and this algorithm is going to process the complete message with this key and made it in a cipher text. So this message is encrypted with the key and come out with the cipher text. So this is what the encryption is processing. Now this cipher text is some random characters, a string of random characters. Now it also contains some spatial characters, numbers, and a complete combination of all characters. This has to be decrypted with the key to send it to the bank from John, decrypted. So you see, this plain text is received to the bank here after decryption. So this complete process is called cryptography algorithm. Is happened in this way. So this is the overview, or you can say an output of a cryptography, and this is what the most popular secured algorithm to work on. Now out of this we are going to process today is encryption. Now let's take a look what is actually RSA algorithm. Now to process this kind of cryptography and encryption process, there are so many ways. So one of the ways is called asymmetric. Now this particular asymmetric cryptography algorithm is named as RSA. Rifist-Shamir-Alderman is an algorithm used by modern computers to encrypt and decrypt the message. It is an asymmetric cryptographic algorithm. And what is that asymmetric means here? That there are two different keys. To make it more secure, you have two different keys which is going to encrypt and decrypt at the other end. And this is also called public key cryptography because one of the keys can be given to anyone. It will be private key. So this is what the private key RSA algorithm. Now let's learn about encryption. Ciphertext is a result of encryption performed on plain text using an algorithm. Ciphertext is also known as encrypted or encoded information because it contains a form of the original plain text that is unreadable by human or computer without the proper cipher to decrypt it. Now, as you can see, asymmetric encryption, and here we have a public key and a secret key. This is a private key. So two different keys are going to process this information, this plain text, and after processing it and encrypted this plain text with the keys, it will show you a ciphertext. So this is what the ciphertext. Now, once the ciphertext is processed, the other end we have to decrypt it with the help of the secret key. This is your private key. Now, this private key will further decrypt the plain. This is how it works. Now, let's take a look at the implementation of encryption. So, in this session, we are going to actually implement an encryption system. Now, there are few steps, and there is an API in Java we called Java Cryptography API. Now, this particular API contains all the classes and objects which you can use to implement encryption and decryption. So, here in today's session, we are going to implement encryption. Let's see the following steps. First thing, we have to create a key pair generator object. Now, what is that key pair generator? Now, since we are going to implement a symmetric encryption process, so for that we need to have two different keys, a public key and a private key, and that has to be paired. So this is what the key pair generator is going to create, a particular object of a key pair generator. Now, once the key pair generator object is created, you have to initialize it. Now, once it is initialized, it will generate the key pair generator. Now, this is just an object you created, and now it will create a key. Now, get the public key, create a cipher object, initialize the cipher object, add the data to the cipher object, and encrypt the data. Now, if you see here, we have seen the plain text is added with the key and algorithm process and converted into the ciphertext. So this is what is going to process today in the encryption. So we have entered the message to encrypt, and this is what the ciphertext created after RSA algorithm to encrypt it. Now this is what the ciphertext. We are going to convert the ciphertext and write it in a file. This is what the objective is going to be today in the encryption implementation. Now let's take a look at the demonstration. Now this is my Eclipse IDE. Let's have a Java application. The Java project. Encrypt, or let's have a cryptography so that we can continue next. In the decryption, you can use this cryptography demo. Inside this application, you can have your source and have a package. It's always good to have a package. It's a coding standard to make it more organized and structured application. So let's have com.myapp package. Now, once this is done, let's make a class of encryption demo. And I would like to have a main method itself, so just include it. Now, since we are going to implement the cryptography, so let's have a cryptography jar API, the Java cryptography API included in your application beforehand. So first thing first, what we have to do, we have to include our Java crypto jar API. As you can see here. So first thing first, we have to include the Java cryptography API jar file, which we have done. Now next step, pair generator. So as you can see, the Java security is already included in my so let's have a key object name, and again the key pair generator and get instance of it, so that now another point. See, cryptography is a very large topic to discuss. It's a complete API to learn. Here, I'm just showing a small example and a demonstration how it works. And there are so many other types of algorithm. So get instance basically in key pair generator, as you can see, it says returns a key pair generator, and that generates the public and private key pairs for the specified algorithm. So you can see here the specified algorithm. So all you need to mention in an argument that what type of algorithm you want to implement. So here we are going to have asymmetric type of encryption, so which is nothing but the RSA type of algorithm. So this needs some throws to have a safe execution or exceptionless execution. To make it more easy, let's have throws algorithm exception. Let's throw an exception. And the next step, we need to initialize it. So for that, what we need to do, we just call it and initialize with your some kind of bits, just to mention that what is going to be length of your key size, using the default parameter set or secure random implementation. So all you need to mention some kind of a key size. So this is what the key size, and once the key is initialized, next is you have to have a key pair. So for key pair, let's give a name of pair, which is going to be key pair generator is going to have key, and we need to generate the key pair. Once this is done, next we need to have a cipher, because once a plain text is converted into the cipher, we need to put it in an object. So let's have a cipher object, and we need to initialize and get an instance of it. The argument for this is going to be mentioned as an algorithm again. So we have seen the RSA. We need to have an RSA and ECB. This is a kind of string, a kind of algorithm string, which is mentioning it in, I'll show you what is actually it is. Now, if you see this, it's showing some error. Maybe I missed something. Okay, we need to have an exception. Dot init, initialize it. And this has to be your, as you can see here, we have two arguments. The first arguments will provide you the encrypt mode, and the second argument will be your pair dot get private or public or class, whatever type of key you want to create. So for now, let's have a public key, because just a demonstration. So maybe we need to have another throws for this particular step. There are plenty of ways you can implement this type of algorithm. Here I'm just showing you the demonstration and a small example how it works. To make it understand, you can implement it many ways. Now once this is done, this is all about the encryption. Now you have a cipher which can be processed. Now we need to give some input. Oh, that input is nothing but the text, a plain message from any person to person. So for that, we need to get an input value from the user. So let's have scanner. Okay, and for scanner we need to have IO util package, and enter plain text, you see, to be converted into the to convert it into the encrypted cipher. Now, once this is done, all you need to have a message converted, initialized with your next string, because it's a string type, so that's fine. Now this is about, now what next, we need to have a byte type of variable which will convert your get bytes and make it in a cipher. Now cipher is further going to update by this particular byte type of variable. Now this message is processed in the cipher in a byte form. Now all we need to have print this byte, or you can say, now once this is done, next what we have to do, we have to save the cipher text. Now this is just a cipher. Now next is cipher text. The plain text is converted into the cipher text, and that is your cipher encrypted in a byte. And then all we need to cipher text. So this is what in a UTF form. So UTF format is the kind of text form. Now once this is done, let's throw the exception, and for this particular statement have another throws. So I'm just giving you an example how we can have it. You can add the throws, you can handle the exception as per the steps you are going to perform. Now so far we have this is your encrypted cipher text message, right? Now we have to write in a file. So for that, what we can do, all you need to open your output stream. There's so many ways to have a file handling. So here I'm just using a file output stream and making a file named encrypt.txt. So this is my file name, which is going to create it after this. And once this is done, all you need to write in your file. That's it. Encryption is implemented successfully by TechCrunch. Just to know it is exit. Now if it is an error here, that means you need to include the exception, change type of word. Oh, okay, I might miss this one. And this is your byte. Actually it's supposed to be ciphertext, because this is what our end method, if you see, throws exception. Yes. So instead of writing in a try and catch block, I'm just simply adding a throws exception. Import java.io.star package for the output stream. Okay, so this is what the execution and implementation of encryption, a plain text to a ciphertext. Now let's take a look at the execution. So since it's a Java application, you need to have it in a Java app. Java console. It says enter plain text. Hi, welcome to TechCrunch. Let's make coding fun. It's encryption demo. So this is my plain text. Now if I entered, encrypted ciphertext message is converted into this. Now this is your ciphertext message, and just if you see, you have another kind of file in your application, which is, just refresh it and see, it is called encrypt.txt, and if you open it, it gives you all kind of encrypted ciphertext message. So this is the demonstration and a live coding implementation of encryption. So we have seen asymmetric encryption implementation. Important facts about encryption and cryptography. Implementation of cryptography in Java is possible by Java Cryptography API. That's what we have seen. All you need to import the jar file. JCA can build their application integrating security in your application rather than depending on the complicated security algorithm. Implement concepts of modern cryptography such as digital signatures, message digest, certificates, encryption, key generation and management, and secured random number generation. So there's so many ways where, and so many places where you can use this. One of the most popular secured algorithm is called cryptography. So far we have seen encryption. In the next session, I am going to present you the live implementation of decryption. So stay tuned. Thank you so much for watching this video, and please subscribe to our channel and get updates on our upcoming interesting videos. Let's make coding fun. Thank you.